Yeah. Class, class. Yes, yes. I was like, right, because much 10th graders can do that. Apparently it works when you're 4. Right? I bet so. When you're 4, you're just happy that somebody's talking to you.
I'll have to.
Just kidding. When you're 16, you're still the same. It's stupid and crazy at the same time. Almost as stupid and crazy as congruent triangle. Yeah.
I have to tell you, when the mic's off, about hard to handle children when I was teaching at the alternative school conference. They said,
Coach, first let me tell you how you can use corresponding sides and corresponding angles to show that.
Hey, listen.
No, you can't call me stupid. I'm going to all right through it. Geometric figures are congruent if they are the same size and shape. Here's what you need to write down. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Polygons are congruent polygons if and only if their corresponding sides are congruent. We're going to be looking at 4 seconds. 1, 2, 3, 4. We'll come back to it. I got things to do today. You don't need to write this down. You don't need to write this down. I was listening to the story. Here's the point of this story, okay? Look at the different corresponding parts, okay? In a triangle, look how it works. A and B, right? A and B has how many tick marks between it? 1. So go to triangle DEF. Its side length has 1 tick mark between it. That's how we will, that is how we will tell which different sides are corresponding. Okay, notice that we got 1 tick mark and 1 tick mark, 2 tick marks and 2 tick marks, 3 tick marks and 3 tick marks, right? Go to the angles. Let's throw this one out there. Angle C corresponds with which angle over here? 3 and 3, correct? Oh, but Mr. Miles, what about when you get down here? All right, guys, no problem. When you get down there, okay, this would be an example of a rectangle, okay? It's a little bit different than how we would describe a triangle, because when I write this in order P, Q, R, S, and then I come over here and I say W, X, Y, Z, I can match up the angles and the side lengths according to the order which I write it. That's how we get P and W as corresponding, Q and X, R and Y, S and Z. Okay? Notice something that I can't do. I can't say this. PQ SR. See that? I can't say that. That doesn't go in order, does it? I could say PQRS. Okay, or I could say RQPS, but I couldn't skip around however I wanted to. P, R to Q to S. That doesn't work, okay? It's got to connect to each other along the side. Makes sense, right? Okay? All right. Don't worry about writing this down either. This is the same thing I just said. It says name a polygon, write the vertices in consecutive order. For example, you can name polygon PQRS as QRSP or SRQP, but not PRQS. Okay? It helps if you draw pictures. It always helps if you draw pictures. Because if you say this and you look at the order of it, you're like, what the heck's going on? And then you draw a picture and you label your picture, it makes it easier, right? I've only got so many ways I can do it. Okay. All right. This helpful pen is helpful indeed. When you write a statement such as triangle ABC is congruent to triangle DEF, you're stating which parts are congruent. Okay. What I want you to understand, the precision with which geometry operates. Precision. You know what precision means? Coach, when you go to Academy School, you go to Academy. Where do you get your golf balls from?
Usually the pro shop. I play Pro V1.
Coach, you go to the pro shop at Allen Mountain,
Yeah, okay,
okay?
okay.
You go to the pro shop at Allen Mountain, and it's golf balls, play the Pro V1, so they're like $15. All right, sleep, no, I'm just kidding. They're probably $3 a sleep. I wish.
Yeah, about 60 a dozen, so
Okay,
about $15 a sleep.
all right, coach. With taxes, that becomes, let's say it like this. Let's say with taxes, that becomes $15.20. Nope, $15.22. Got me?
Yes, sir.
Coach, you hand them 16 total dollars.
Yes.
Got me? How much change are you supposed to do?
78 cents.
Okay, so you hand them 16 bucks. The total cost was $15.22. We subtract this out.
78 cents.
78 cents, right? Coach, that's how much you're supposed to get back, right?
Right.
The lady gives you 3 quarters.
So
You walk away. Does she give you the precise amount of change?
she did not,
Why not?
because it was not exact. It wasn't the correct amount.
I drew close though. It
What,
don't matter.
what, close enough.
Wasn't close enough. Now, you want to know why we're so concerned about precision? Tell you why. I had a friend in college who had a friend in high school. I never met this guy, unfortunately. Coach, they lived in Nashville, Tennessee. They did pretty much anything they wanted to. You know why?
They had a lot of money.
Well, they did because in the 1980s, his dad was part of the patent that invented the credit card swipe machine.
All right.
Okay? Y'all know credit card swipe? Once upon a time, there was not credit card swipes. All right? And for every time that a credit card is swiped in the world, you got like 1/100 of a penny or whatever it was. Which if you think about all the times credit cards have been swiped since 1983, and that's a pretty decent amount of money, right? That's enough you can probably buy a yacht with. Got me? And it works because there's precision involved. There's a difference between 78 cents and 75 cents. There might not be to you that much difference, right? But if you multiply that 1,000,000 times over,
It's like,
you multiply that 3,000,000 times over, you become a millionaire.
it's kind of like that extra number when you get gas.
It's that
Where'd that extra 9 come from?
number that those gas station operators like to charge, right? It don't matter that much. Yeah, but it does when you're seeing hundreds of thousands and then millions of customers, okay? So, no, it's not the same. You're not going to be losing any money here, okay? But that's why our precision is important for us. You need to learn how to be precise with certain things.
Like you're building something. You got 12 people building it. And somebody's off an inch. Everybody else gets off an inch. Well, you say it's just an inch, but 12 people off an inch turns into
Good.
a foot. That ain't real good when you're trying to level something up.
Nope, that ain't gonna be building my house, okay? This is how easy it can be. Triangle, PQR is congruent to triangle STW. Identify the corresponding parts. Angle P is congruent to S, Q is congruent to T, R is congruent to W, and so on and so forth. Right? What would be the first thing to do here, Tyler?
Draw a picture. I don't know what y'all think I do.
Guys, first thing you're gonna do is draw a picture. Now try this one. Try this one. Okay. Polygon LMNP is congruent to polygon EFTH. Identify the pairs corresponding congruent parts. I know. All right. Tyler Tracy, let's try this again. What's the first thing you're gonna do? Perfect, Tyler. Okay. It doesn't have to be a very good picture. Is mine very good? It's not very good. But Tyler, as long as I label this LMNP, correct? And then I come over here and draw another picture that is supposed to be the exact same, not the exact same, and label it EFGH. H, now I can visualize the corresponding points, okay? Tyler, what is angle L going to be congruent to over here? E. M and, see it? N and what? Good. And what about H? Good deal. All right, y'all see that one? So the angles are pretty easy, correct? Angles are pretty easy. My angles are just L, M, N, P, congruent to E, F, G, H. And you think that the sides are really complicated. And guess what? They're not. Briar, what's the top side of the left polygon? What point to what point? Top side of the left polygon. Over here. Top side. What are the points between it? Okay. From L to M would be congruent to what parts over here? E to F. About the right side. That's it. M to what? M to N, congruent to what? F to G. And so on and so forth. N to P, G to H, P to L, H to E. That is the corresponding angles, corresponding sides. That's simple, okay? See why we draw pictures? Yeah. See why it's precise. I said LM and FG look about the same. Not precise, is it? Okay. Be precise with everything. Let me show you what it might look like today. Okay. If triangle ABC is congruent to triangle BBC, I wanted to find the value of x in this example. If the two triangles are congruent, angle BCD is congruent to angle BCA, right? Yep, angle C's in both of these two triangles will be congruent. What does this box mean? 90 degrees. How much is my value here? 2x minus 16. That means that 2x minus 16 has to equal 90. Okay? Substitute my variable or my expression into an equation. Set it equal to 90. Solve for x. Add 16 both sides, divide both sides by 2. Next, I might have something like this. Find the measure of angle BBC. BBC. Okay? Just learned this about right triangles. If this angle is 90 degrees and this angle is 49.3, note 90 plus 49.3 plus 10
X
would have to equal what?
about 42 something.
180.
Doing it? Oh, yes, okay.
90
Not
plus
the actual.
49.3 plus 10 would have to equal 180. Okay?
Because of the triangle sum theorem says that all angles equal 180.
You got it, dog.
My bad. I thought you meant what would be the actual.
They do this for us and tell us that's 40.7. Okay? Notice that the question says, what is this angle right here? Well, this angle DBC would have to be the same as angle ABC. Okay? It's a corresponding angle. Right? Why don't you guys do this one for me? Draw it out, work it out. They've drawn the picture for you here. Okay? Coach is not right on this. Okay?
Sorry.
But, no, it's okay. I'm just letting you know.
I just,
No, it's okay. Alright, find the value of x. What side, where is this x located? Yeah, what side is that on the triangle? A to B. A to B, which is 2x minus 2. You see that? Right? And what side on triangle DEF corresponds with AB? DE. AB and DE. What does DE equal to? Wow. What do I do to solve for x now? Add 2 to both sides. 2x equals 8. What do I do now? Divide both sides by 2. What does x equal? Quattro. That's how it was before. Question. E to F is 10. What would B to C be? EF is 10. What is B to C? 10. That's an angle number. Angle B is 53. B to C would be 10 because it corresponds to B to F. B to F is 10. Okay, check this one out. This is our end goal. We're trying to get to be able to solve these types of problems. I'm given that YWX and YWZ are right angles. YW bisects angle XYZ. W is the midpoint of XZ. XY is congruent to YZ. Given a lot of information there. Bisector. I'm sorry, a midpoint will cut the segment into 2 congruent points. YW would be congruent to itself with the reflexive property. XY is congruent to YZ. I'm given that particular information. Look at what I'm going to try and end up doing when all this is set up, okay? Okay. I'm going to try and get these proofs completed. This is our end goal. We want to be able to do this by the end of the year. Really not the end of this unit, but certainly by the end of the year, okay? My statements on the left, my reasons on the right. Given this information, right angles are congruent. I know that because of the right angle theorem. YW bisects XYZ, I'm given that. That means that XYZ is congruent to ZYW. That's the definition of a bisector. Given the midpoint, we talked about what the definition of midpoint means. We talked about the reflexive property. One thing I failed to mention here. This is the bisector. How many angles do I have congruent to these 2 triangles now? Yeah, well, I've got 2 congruent as it stands, which means through my third angle theorem, I can conclude that the third angles are themselves congruent. 3 sides, 3 angles, those triangles are congruent. Again, probably not something that